For this problem, you can look up the answers for 1 and 2 and 3 on the key that's on Moodle. I want to talk right now about the electron dot structures, first for sulfate. Sulfate is a polyatomic ion. My S and my 4 O's each have 6 electrons. So if I take 6 times 5, I get 30 electrons. And there's 2 extra electrons from this, which means I have a total of 32 electrons. That's how many I have. If I figure out how many electrons I need 5 times 8 equals 40 electrons, plus I've got 2 electrons total, extra, equals 42. That gives me 10 divided by 2 equals 5 bonding sites. So in order to do this, I would have to use this format. That I'd have to put this in parentheses and give it a 2 minus. Now, this works if you do it, it works other ways. Works other ways. This also exhibits resonance as written, because without writing the whole thing, I could have, just real briefly, my double bond here, my double bond here, and my double bond here. So I would have resonance with those structures. I just don't have room to write all those. This is a little bit different because check sulfur. As sulfur is written here, it has 10 electrons, or 10 electrons, which violates the octet rule. I'm going to turn this off and make this bigger. The way that we would usually draw this in order to not violate the octet rule would be S, and these would all be coordinate covalent bonds with our O's, and then all of these would be like this. Again, I'd put this in parentheses with the 2 minus. This would be what I would expect you to give me. Because the math doesn't work so well. And if I count these, I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So this would also be correct, and this is the way I would expect most of you to write it. Next, we have OH minus. So I have O that has 1, 2, 3, 4, 5, 6. Now I'm going to put an H right here with its electron. So life is good. Now I've got a negative charge, which means that I have to add my 8th electron right there. So this would be with a -1 charge. So that's the way we would draw those. Okay, let me see here. This would be boron, which has 3 bonding pairs, beryllium, which has 2 bonding pairs, phosphorus, which can have 5 bonding pairs, and sulfur, which can have 6 bonding pairs. This is trigonal. There's several: trigonal, planar, linear for beryllium, or it can be octahedral or trigonal bipyramidal. And this causes polarity. Why isn't this working? Okay, I guess I'll be done.